Okay, hi everyone. Thank you so much for joining us here today. My name is Alice Deneen. I'm the Technical Sales Geologist at Geotek Limited. Today we'll be speaking with Northwestern University. It's great to see you both. Thank you so much for joining us here today. So to start, could I ask you to tell us a little bit about yourselves in relation to your roles at Northwestern University and some of your main research topics?
Sure. Hi, I'm Yarrow Axford. I'm an associate professor in Earth and Planetary Sciences at Northwestern, and I teach courses on paleoclimate, Earth's present-day climate system, and contemporary and future climate change, mostly. And my research looks at past climate change with a focus on the Arctic.
Okay, great. Thank you so much, Yarrow. And Laura, could I ask you to give us a quick introduction of your research and your role at Northwestern?
Hi everyone, my name is Laura Larocca, and I recently finished my doctorate degree at Northwestern in the Department of Earth and Planetary Sciences with advisement from Yarrow, Axford. And my research primarily focused on understanding past glacier change and past climate change in Greenland.
Okay, great. So with that in mind, I was going to ask you today about your recent research.
So the research in South Greenland really focused on the question of better understanding the timing and magnitude of warming during the Holocene. So throughout Greenland, there was a warm period in the early Holocene called the Holocene Thermal Maximum. And that warm period varied geographically in its magnitude, so how warm it got across Greenland and when that period of warming occurred. So our main objective was to test that hypothesis by looking at glacial lake sediments. So in 2018, we traveled to South Greenland, and we traveled to 3 lakes that currently have glaciers in their watersheds to collect sediment cores. And this photo in the background here shows myself standing with my colleague, Melissa Chipman, and we're holding up a sediment core from one of our lake sites. So the broad idea is that lake sediments accumulate year after year at the bottom of lakes, and those sediments can serve as a record of the environmental history and the glacier history around the lake. So we measured the geochemical and physical properties of that sediment to determine when glaciers were on the landscape in the past and when they melted away or were smaller than present. So our data gives more evidence that warming was delayed in South Greenland relative to other areas.
I wanted to ask how you actually used the multi-sensor core logging system and what the impact was of this.
Yeah, so we use the Geotek multi-sensor core logger essentially to measure physical and geochemical properties of the glacial lake sediments. And we did this to distinguish when a glacier was on the landscape and when the glaciers were melted away in the past. So our system includes a Barrington point sensor, which measures magnetic susceptibility. It includes a Konica Manola spectrophotometer, which measures visible color reflectance, and also a Delta Professional X-ray fluorescence spectrometer, which measures major element abundance.
Something that's really useful about the MSCL for our work is the fact that we can learn so much about sediments without destroying them, without even sampling them, so leaving them completely intact. And you can imagine that getting these samples from a place like Greenland is an enormous undertaking. We're given the privilege of visiting Greenlanders' land to get samples and do our research. Because the logistics are so involved, we rarely are able to return to these sites ever again after visiting them. And so we kind of got one chance at getting samples, and we've got to do all the science we want to do with that mud. And so the ability to split open a core and scan it and learn so much about the composition of the sediments without consuming any of that mud at the beginning of a study is just really helpful.
No study had documented historic or Holocene length changes in local glaciers in South Greenland. So it was a really important region that had very few scientific studies before our study. We found also that shifting ocean currents play an important role in climate and glacier change there. The study also helped us to better understand regional climate and also the climate of a warmer world where we're heading. And it also provides sort of a long-term framework for anticipating the consequences of anthropogenic warming. One of the, I guess, other implications of our study is that we found that temperatures in the early Holocene are below the projected temperatures for the end of the 21st century, and that information implies that South Greenland's small local glaciers are probably doomed to melt away by the end of the century.
It's always so important to explain why our research matters, and in this case, we're talking about climate shifts past and present in the Arctic, and the Arctic is warming faster than any other part of the planet today. And we know that it has experienced large climate swings in the past, but we also know that the causes are very different from the human causes behind today's warming. And we've long known that, in particular, over the last 10,000 years, the Arctic has experienced a long-term slow cooling for natural reasons. And in fact, that trend would be continuing today if it weren't for human activities, and especially adding CO2 to the atmosphere. And so because we have this long, slow cooling to look at in paleoclimate records, we can look at how glaciers respond to that climate change and also to the warmer climate that you had in the beginning of the Holocene before that long, slow cooling happened. So it's really an opportunity to look at a warmer Arctic and ask, how did glaciers and how did the Greenland ice sheet respond to that warmth? And Laura's work adds to a growing body of work that shows that, as she said, in that earlier warm time, when the Arctic was just a bit warmer than it is today, an awful lot of glaciers disappeared, and most, if not all, were significantly smaller than today. So we know that the Arctic lost a lot of ice.
I wanted to ask if there were any entities or organizations that you wanted to acknowledge or that contributed somewhat to your research projects at all.
Thanks so much for asking. Our work is primarily supported by the U.S. National Science Foundation, and their support really makes it possible. We have also had support from the National Geographic Society, and the people of Greenland have given us access to their land, which we very much appreciate. It's very necessary to do this work.
Could I ask what sort of research projects you have planned for the future?
So I will be starting a postdoc in a couple weeks, and that postdoc will be focused on modeling glacier change, specifically glacier birth in the mid to late Holocene, and projecting glacier death in the future across the entire Arctic. And this is important because we know that glacier loss has a lot of local implications. And so knowing exactly when glaciers across the Arctic will essentially melt away is really important for local communities and meltwater output that's used for a lot of different things.
I'd like to thank you both so much for joining me here today. If anyone has any questions at all, feel free to contact us at sales@geotek.co.uk. Yarrow and Laura, thank you so much for joining us here today, and good luck with any of your future research projects. It really sounds like you're really doing some important work for understanding our global climates. Thank you so much.